Alright, this video is a continuation of our piecewise notes from our previous class. I'm on page 9 of the packet. So right here you're given a graph of a function. I actually want you to write two different equations. I want you to write a piecewise definition for this function. A piecewise definition using at least two pieces. And then I want you to write an explicit equation. You're on video. An explicit equation means write one equation for that picture. So I want you to do both. I want you to write me one equation for that picture, and then I want you to write me a piecewise definition using two pieces as well. If you're following along at home, you can pause the video and try this and then check your answer.
We're doing it by ourselves.
Yeah, try it by yourselves. Everybody's trying it by themselves.
Oh, sugar love.
Sugar honey iced tea. Live, and we're back. Okay, let's start with the explicit. We could write this as an absolute value function that's been shifted which way? Down to right one, so we could have the absolute value of x. The right one is -1, the down 2 is -2. Has there been any kind of flip or stretch? Ooh, because normally it has a slope of 1, so this has been stretched by 2. Thumbs up if you got the explicit equation of that, a few of you. Okay, now for the piecewise, I'm going to write both of these as linear functions. They're going to have different slopes and different y-intercepts. This first piece should have a negative slope of what? Negative.
-2.
All right, -2.
X.
Can you tell what the y-intercept is?
0.
That's 0. Okay, so that's the equation we're using for the first piece, is just -2x. Second piece should have a slope of +2 up to right 1. Extend this down so you can tell that the y-intercept would be -4, right? Okay, then put your restrictions. The first piece would be if x is less than 1, and the second piece is x is greater than 1. Where do I include that actual point? It doesn't matter, you just have to pick one. You just cannot pick both. So just pick one, it doesn't matter. X equals 1 on either piece, not both. If you want to make yourself a note, x can equal 1 on either piece, but not both. I will take off points off your quiz and your test if you include it on both of those. Okay, questions on writing the definition?
No.
All right, the last skill that we're going to have for the piecewise functions is if I give you a piecewise definition like this function f, 3 different pieces, you've got a linear, a constant, and a quadratic. You should be able to evaluate the function algebraically without a picture. Without a picture, okay? It's easy when you have a picture. I say, what's f of 3? And you go, boom, boom, it's 2. But when you don't have a picture, you should still be able to evaluate, okay? Now, let's say we have a plain old boring function, and I want to find f of 2. What do I normally do? You plug in 2 for x, okay? Now, here's the problem. There's a lot of pieces with x's. So which piece do I plug it into? All of them?
The f of x ones.
I heard just the top one. Alright, so let's say this is piece 1, piece 2, and piece 3. What's your vote? Which piece should I plug 2 into?
Well, you can't really do it to piece 2, so.
Why is it piece 3? Because that's the only place that x equals 2 is defined.
Huh?
You're only going to use this piece if x is less than -2. And you're only going to use, stop please, and you're only going to use this piece if x is between -2 and +1. So if I want to find f of 2, I have to pick which piece that x is defined for. Does that make sense?
No.
Okay, so 2, where does 2 fall? Is 2 less than -2, between -2 and 1, or greater than 1? Okay, great, we're going to use this piece. Yes?
Is it always going to be where it only works for 1?
Okay, that's a great question. Could I have 1 on 2 different restrictions?
Sure.
Why can it not be on both pieces? Because then it's not a function, because then you'd have 2 points stacked on top of each other. So yes, your restrictions will always be exclusive of each other. If they overlap, it is not a function and you have a bad problem. Okay, so f of 2, since 2 is greater than 1, we're going to use the third piece. So we're just going to do 2 squared is 4. You have to show me your work. I know that you guys can do 2 squared in your head. Why do you think you have to show me your work on this?
So that you know you selected.
So that I know you picked the correct piece. I'm like, hey, you picked the x squared piece. Very good. That's how you got that value. Here, this right here is not something that you have to write. I'm just writing it down for notes. We are using the third piece since x equals 2 is greater than or equal to 1. It fits in this category, okay? All right, f of -3. Look at your restrictions. Where does -3 fall?
The top one.
First piece?
Yeah.
Is that less than -2?
Yeah.
Yes, we're going to use the first piece for this one. So how do I calculate f of -3?
You plug it in.
-2 times -3 plus 1.
7.
7.
7.
For this example, we use the first piece since x equals -3 is less than -2. Again, you guys are not on your homework. You're not required to write the justification for why you picked which piece. I'm writing it down so when you go back and look at these notes, you know why I picked that piece. Okay. f of 0, which piece is this defined for?
The middle one.
The middle piece. So right here, 0 falls between -2 and 1. Guess what?
What up?
There's no work. For any of these x values, the y is just -1. What does that look like on the graph?
I thought it was just a point. What? Are you mad at me?
This one is a point, but this one is a horizontal line because look at my restrictions. If you have it just at one value, it's a point. If you have it on an interval, it's going to look like a piece of a horizontal line. So this is a piece of a horizontal line from -2 to +1. Does that make sense, everybody? What are your questions? Because you're going to have to do that on the homework tonight. Okay, next. How do you find x-intercepts algebraically? Just like in general. You set the y equal to 0. You set the whole function equal to 0 and solve for x. While we're discussing this, how do you find y-intercepts algebraically? You set x equal to 0. In other words, you find f of 0. Okay, let's do this one first. f of 0. Psst, we already calculated it.
1. -1.
It's -1. Great. You can only have one y-intercept. If you have more than one, it is not a function. Cool. All right, the x-intercepts are a little bit more complicated because we have to set the y equal to 0 or set the f equal to 0. But I have 3 different equations. Which one do I set equal to 0?
Oh.
All of them. Correct. We're going to set each piece equal to 0 and see if it has any solutions. So let's try that. We're going to set 0 equal to -2x plus 1. We're going to set 0 equal to -1. We're going to set 0 equal to x squared. Set every piece equal to 0. All right, let's solve each of those equations, little equations right here. Subtract 1, divide by -2. Divide by -2.
1/2.
So what's your final answer?
1/2.
Positive 1/2. You had said negative, and then you said a half. And I didn't know if there was a comma in between those or it was one answer. You understand my confusion?
We don't know what you said.
Okay, so x equals 1/2. Great. Second equation, 0 equals -1.
Hey, can't do nothing with that.
That's no solution. 0 cannot equal -1. There's not even an x in there to solve for. Okay, last piece, if 0 equals x squared, what does x equal?
0.
Take the square root, you get 0. So that's it. Those are my x-intercepts. You have to check if these x values are in the correct domain for that piece.
What?
You have to check, are these x's in the correct domain for that piece that you use to find it. So look at this first one. I use this piece, right? Is 1/2 less than -2? No, this is not one of your x-intercepts. This is not in the domain for the first piece. Okay, and then that wasn't a solution. Here, third piece. Is 0 greater than or equal to 1?
No.
This is not in the domain for the third piece.
Child, real wrong with that.
So what are we doing here? What does that mean?
I don't know.
So the question is, what are the x-intercepts?
None.
There are none. There are none.
That's
Therefore, none. You're right. This piecewise function would not cross the x-axis anywhere. Based on the restrictions, right? This is why you have to check the domain, because this line normally does have an x-intercept here, but I only want the piece of the line that's less than -2. So that piece of that line will not cross the x-axis because that's not in the domain. Does that make sense? You're looking at each piece individually, okay? All right, now I want to know what is the domain of the whole function. This is actually easier than you think. You're just going to take in each of these mini domains and you're going to squish them all together and you're going to have one big domain. Okay, look at the first piece. What's the domain? -∞ to -2, parentheses or bracket? Parentheses. Middle piece. -2 to 1, bracket on the -2, parentheses on the 1. Third piece.
Parentheses on what?
Bracket 1 to infinity. So now we're going to unionize these all together. And what would I get if I combine them all together?
A big happy family.
What?
A really long domain.
Yeah, what is it? Is every single x value accounted for?
Here.
So we're going all the way from -∞ to -2. We're including -2 to 1. We're including 1 to infinity. That's all x values. This function is defined for all real numbers. It's just in 3 separate chunks. So yes, to find the domain of your piecewise, you just combine all the mini domains of each of your restrictions together. Combine all mini domains together. And then that would be your answer down here. The domain is all reals. Again, we haven't even looked at a graph of that picture. We figured all that stuff out just from the definition of the piecewise function. Questions? All right, I'm going to stop this video here and start over in a new one.